Today we're going to graph linear inequalities. So a linear inequality for an equation, it is y equals mx plus b, as this first one is. So y is equal to 2x minus 8 is a linear equation. We can graph that. We know how to graph those. And then the next one, a linear inequality, we switch the equal sign with those symbols. For example, y is less than 2x minus 8. A linear inequality is almost exactly like a linear equation, except for a couple tiny differences. So first, we're going to graph with the equal sign. We know how to do this. The slope is 3, and the y-intercept is -4. Remember, the slope is 3 over 1, so it's rise over run. And we start at -4. So rise 3 and run 1. Rise 3 and run 1. And we can keep doing that. And then we know that that is a line. So what that line represents the solutions to y is equal to 3x minus 4. So that line represents all the solutions to that equation. What that means is if I pick a point on that line, let's say 1, 2, 3, 1, 2, 3, 4, 5. So if I pick this point and I substitute x is 3 and y is 5 into here, I would get y, which is 5, is equal to 3 times x, which is 3, minus 4. So x is 3 and y is 5. I should probably choose a darker color than that. So now I'm going to do the right side. 3 times 3 is 9, which is a true statement. So the line represents the solutions to y is equal to 3x minus 4. Any point on that line, this point is 0, -4. You can either follow along. So if we put -4 in for y and 0 in for x, y, which is -4, is equal to 3 times 0 minus 4. -4 is equal to -4. If we pick any point on that line and we substitute x and y, we get a true statement. So that's a little bit shorthand. So we're going to pick any point on the line. If we substitute x and y into that equation, we're going to get a true statement. Just lost it. Now graphing inequalities is very similar. So we still graph the slope, and the y-intercept is -4. So we still go up 3, right 1, up 3, right 1, and so forth. So before I graph this line, we're going to pause for a second. What we are graphing is the solutions to this inequality. So if I pick a point, let's say I pick this point 0, -4, and I substitute it into that inequality. So -4 is less than or equal to 3 times 0 minus 4. -4 is indeed less than or equal to -4, so that's a true statement. Any point on that line is going to be a solution to this inequality. So that means that we make this a solid line. But with inequalities, we know that inequalities represent multiple solutions. So we are going to have to shade inequalities. That's the other difference. To figure out where to shade, there's a longer way and a shorter way. So I'll do shade. We're going to pick any point. I'd like to pick 0, 0. Because that means that x is 0 and y is 0, and it's easy to do the math with 0, 0. So we substitute it in. And we see 0 is less than or equal to -4. Is that a true statement? Absolutely not. That is not a true statement. So where this blue dot is, no other point in there is going to be a solution. All right, so now we're going to pick another point. And maybe we'll pick, I don't know, 3, 0. It doesn't matter what point I pick in this region. Below that green line, I'm going to pick any point in that region. And just backtracking, there's two different regions here. There's this region and there's this region. One of those regions is going to be a solution to the inequalities. We know this region is not. Maybe that one is. So we're going to pick a point, 3, 0. We substitute it into the equation. We get 0 is less than or equal to 9 minus 4, which is 5. That is a true statement. Since that point is a true statement, we are going to shade below this line because it's where that point is. So whichever one is true, that's where we shade. So any point in here that I choose, I can go through this and I will get a true statement. If your sign is less than or equal to, we're going to go to this graph and shade below it. If this symbol is less than or equal to, we go to that line and shade below it. Get a bright color. So two of the things we're going to have to determine is if the line is solid and where we shade it. We always use, like this says over here, a solid line for less than or equal to or greater than or equal to. So when I graph the next one, the slope is 3 over 1, just like before. The y-intercept is -4, and the line is solid. Because any time that we have an equal to symbol, when we pick a point on that line, it's going to be true, just like up here. Those are the points on the line. So again, we graph the same line. And it's solid because it has that equal to symbol. A solid line is if it's, oops, don't want a yellow one. Solid line for less than or equal to or greater than or equal to. So a solid line for less than or equal to or greater than or equal to. Because the solid line shows the points on the line are solutions. Now we have to figure out where to shade. This one says y is greater than or equal to 3x minus 4. So we're going to figure out where to shade. And these problems do get easier. I'll show you in the next page. So we're going to pick any point. I like to pick 0, 0 again. And I'm going to see if it gives me a true statement when I substitute it into there. So 0 is greater than or equal to 3 times 0 minus 4. 0 is greater than or equal to negative 4. That's a true statement. That means any point in here will give me a true statement. So I shade above this line. When it's greater than, you shade above. When it's less than, you shade below. Greater than, you shade above. Less than, you shade below. It doesn't matter if it has the equal to symbol underneath it or not. Greater than is above, less than is below. We go to any point on that line and we shade above that line. So we shade all these points in here. Now we're going to look at if it's just a strictly less than or strictly greater than. So there's no equal to on these two. So again, I graph my slope, my y-intercept, all right, so now again, we're going to check those points on that line to see if the points are included on that line. So I'm going to, let's do this point again, just because. So we're going to see if that point is on the line. And that point is 0, negative 3. So negative 3 is less than 3 times 0 minus 4. Negative 3 is less than negative 4. That's not a true statement. None of these points on this line then will be a true statement. Since this isn't a true statement, none of the points on that line will be a true statement. So we make a dashed line. If it's strictly less than or strictly greater than, none of these points on the line is going to make that inequality true. So it's a dashed line. Because it's less than, it's strictly less than, there's no equal to, it's a dashed line. If there is an equal to, it's going to be a solid line. Now again, we need to know how to shade. We can either pick a point 0, 0 and see if it's true, or since this is less than, I'll write the symbol, since it's less than, we shade below. So since it's less than, we shade below the line. So we go to any point on this line and shade below it. You don't have to stay in the lines. You don't have to make it perfect. Just let me see that you can know how to shade it. Again, the next one, start out the same way. The slope is 3 over 1. The y-intercept is negative 4. Just like the last problem, this is going to be a dashed line because there's no equal to. We are not including the points on this line. They're not solutions. We don't include the point on the line. So I'm going to make a dashed line or try to make it look dashed as best I can. And then we're going to figure out where to shade it. Again, like before, if it's greater than, it's going to be above that line. So I go to any point on that line and I shade above it.